Hello, scholar. Welcome back. Today we will be discussing about Python's most underrated data structure, that is tuple. Sometimes we overuse list, but there is another data structure format that is tuple, and it is incredibly powerful. So in today's video, we will discuss where we can use tuple in a very efficient way, which can increase your programming efficiency. Just for a recap, what is data structure? Data structure is nothing but a group of data in a specific structured format. Precisely, you can say it's a specialized format for organizing, storing, and manage data. That is simply data structure is. Okay, so before we move further, let's just talk about where the name tuple comes. So it's basically refers to the sequence of varying lengths like single, double, triple, quadruple, quintuple, and so on. Now, what is tuple? If you go by the definition, a tuple in Python is ordered, immutable, heterogeneous sequence of Python objects defined by parentheses. Is it too difficult to remember? Oh, actually it's not. Let's break down each part of the definition. Once you understand the definition, I'm sure that you will have a complete clear idea about tuples. Let's start from here. Defined by parentheses simply means that all the elements of a tuple will always be inside the parentheses. Okay, and as its multiple elements, that will be separated by comma. Okay, the next is sequence of Python object. That means multiple objects, the tuple can hold multiple data, multiple elements. Heterogeneous means this tuple can have any kind of data, multiple different kind of data. Means in a single tuple, we can have integer, float, boolean, strings, any kind of data, mixture of data. Immutable means once this tuple is created, you can't change it. What that means? That means neither you can add anything to the tuple, nor you can delete anything from it. In fact, you can't change the positions of the elements. Whenever a tuple is assigned, that will assign forever. You can't change its structure. Now, ordered. Ordered means all the elements will have a particular index. That means starting from 0, 1, 2, 3, and so on. Okay, so I think the definition is much more clear now, and we have started understanding the behavior and the functionality of tuples. Now let's try to do this practically. Whatever we have learned so far, just try to apply this. Okay, so if we want to define a tuple that is defined by parentheses and heterogeneous sequence, that means it can hold any kind of data, right? An integer, string, and a floating point number, and a boolean. Check the data type of this, and this is a tuple. So just check whether it is matching with the definition or not. This is defined by these two parentheses, and it can hold any kind of data. That is, this is integer, this is a string, this is a float, this is a boolean, and it has a particular order, right? So this is the 0th index, this is the first, this is the second, this is the third. Whether it is immutable or not, we will check in some time. I mean, after some time. This is the very conventional way you can assign a tuple. Okay, but there is another way. From other sequence like list or string, you can convert them into a tuple. It's a very simple process. Suppose we have a list of integers, say, like this, okay, and we want to convert it into a tuple. Now first check the data type of this. Data type of this, it's a list, right? If we want to convert it into a tuples, just simply write tuple list. We are just passing this list through this keyword tuple. Now see, we are getting this. Now if we check the data type of this is a tuple, okay. So from any sequence of data we can convert it into a tuple. Suppose we have a string, say name, say string, okay. So this name is a string, type of name will be a string. Now if we convert this name into a tuple, what this will look like? Tuple and name. See, we are getting all the elements, all the letters as a different elements, okay. So this is another way we can convert, we can assign a tuple from another list, from a string. Okay, one more interesting thing is there. We have already said that tuple can hold multiple data. So can tuple hold a single data? So let's see. See, suppose there is a variable a and we are assigning a say 2. What will be the data type of this? Let's check it. It's integer. So what that mean? That mean doesn't tuple can't have a single data? Yes, actually can. The assignment will be a bit different. A to comma. Now check the type of this A. Say it's a tuple. So a tuple can hold a single value as well. There is another way, another approach of assign a tuple using named tuple. So from collections, import named tuple, okay. And from this, suppose say you are creating a person's profile, say we're just creating a tuple like this, person named tuple, and inside this named tuple we are just assigning the variables or the data or the elements we want. That is person, and a list consists of the behavior or the profile of that person, say name, then age, then say city, okay. And how to insert elements here? Just simply call this person and the data will automatically stored in this sequence. And how to do that? Suppose say we are doing employee and we are calling this person and we are just entering the data. Say suppose the name, first one is name, so just name is John, maybe the age is 30 and the city may be say Delhi, okay. So this, sorry, okay, so if we print this employee, say employee age we want, so employee age, see 30 we are getting. If we print the employee say city, we are getting the city. This way also we can assign a tuple. So till the time we have seen the behavior or the structure of a tuple, that it is defined by the parenthesis and can hold different kind of data. Now I have a question for you that what do you think? A tuple can hold another tuple? Like a tuple can have a tuple, another tuple as element? Let's see. Say tuple 1, and we are just defining, say it's an integer, or say root is a data, another data type. Another data type we can add here is a different tuple. See, okay. So now if we check the type of this one, it's a tuple. That means this tuple, this is another tuple, this tuple is inside this tuple, and this kind of tuples are known as nested tuples. So far we have seen how can we define a tuple, then how can we define a tuple from a list or from a string, and how to use the name tuple and the definition of nested tuple. As we discussed earlier that tuples are basically immutable. That means after the creation, after the assignment of the tuple, neither you can add anything or delete anything, right? So let's see whether this works, how this works actually. So we are assigning a tuple, say, just for our easy understanding. Okay, now see, let's try to append something. Tup1 dot append, and say a variable, say 7 we are adding. Okay, tuple object has no attribute append. Now let's try to delete something. Delete tuple1, and say I want to delete the third element. Tuple object doesn't support item deletion. That means once a tuple is created, you can't change the position of the elements, you can't add any new elements, you can't delete any elements. That means tuple kind of elements are, tuple is basically providing much higher data integrity. Now, how to access the existing elements of a tuple? Suppose in this case, we have this elements, right? Now I want to say access the element 3 or the second indexed element, as the indexing starts with 0. So what we can do, we can simply print tuple 1 and the index value, say as it's 2. So we can access this 3. Also we can store this value in some other variables as well. Say tup1 and the index, say third index, that means the fourth one. And if we print a here, then what we will get? We will get 4. This is how we can access the value. One more thing, you can see whether a value is present in that particular tuple or not. We can check this. How we can check this? We just call the index parameter, like tuple dot index, say 3. 3 is in the second index. So these are two different type how you can access the elements. This is by the index number and this is by the value. That means instead of 3, if I say ask for 37, this value is not available. That means I'm putting this value here and searching the index number where this value is present, and in this case I'm just putting the index number and we are just retrieving the value. So these are two different approach. As we were talking about accessing the value of a tuple, this is also known as tuple unpacking. Suppose this T1 tuple, we have this tuple and we want to access all these items, all these elements of this tuple and store it to variables. Like how can we unpack this as a tuple and can store into the value variables? So how can we do that? Just there are three elements, a, b, c equals to t1. Just simply writing this. Now if we print this a, b and c, the values are 1 2 3. But one more thing is you have to remember, that is, instead of three elements are there, but I want to unpack, say, two elements. Okay, is it possible? No, it is not actually. Say x y equals to, if I write t1, value error, cause unpacking means, you know, you have to put all the elements somewhere. You can't choose the number of elements. Okay, so whenever we are unpacking, suppose a value, number of values, number of elements in a tuple is, say, 10, you have to unpack them together. Okay, so this is how we unpack the values of tuple. But there may situation come that you want to pluck few elements, or the elements from the beginning you want to pluck from a tuple, and others there is no need of that. So how can we do that? I want to pluck one, the first one only. So how can we do that? We can do this using star rest. Like, say, a comma star rest equals to tup1. Now if we do this and if we print a, we have successfully unpacked the value of a. Okay, and the other two values has been transferred to this rest element, C. But a constraint is here. Only you can pluck from the beginning, not from the middle or from the end. You have to pluck from the beginning and on a sequence, like 0 1 2 3. Only these three values you want, then you can do this. Also, we can concatenate, we can add two tuples, not the numerical addition that 2 plus 2 is 4, but we can add the elements of two tuples. Like, suppose if we have a tuple of, say, 1 2 3, so sorry for that, 3, and another tuple is t2, and the values are 4 5 6. Okay, and if we want to add this or concatenate this, t1 plus t2, what we are getting? We are getting all the elements together. So this is tuple concatenation. Okay, instead, one more thing to say here, if we multiply this tuples, like, say, print, and we are just multiplying this tuple with 4. Okay, so then what we will get? We will get the same items, the same elements for 4 times. Okay, so these two operations can be done in any tuple. Another commonly used tuple method is count. That means occurrence, to find the occurrence, number of occurrence of a particular value. Say if we have a tuple, say tup3, and the values are, say, 1 1 1 2 3 1 4 3 2 2 2 3, and so on. Okay, so if we want to know that how many times 2 is occurred, so we can do this using top3 dot count, and for what, for the value, for which value we want to find the number of occurrences. If we say 3, see, 3 is for 3 times, 1 2 3. Now if we do this for 2, 2 is for 4 times, 1 2 3 4. So this is how we can check the number of occurrence of an element in a tuple. Now, one question is that the methods, the utilities, the functions we learned about tuple, these are more or less, not more or less, all the functions are available, all the methods are available for list. But why should we use tuple? Why not list? Why tuple? Tuple, first of all, the data integrity of tuple is much higher than list, as it is not mutable, that it is immutable. So in case of, suppose you are transferring or you are storing some kind of coordinates, that means a small change or a small mistake can change the entire scenario. Suppose you are storing some RGB color numbers. Okay, so this kind of thing where a small change can change the entire scenario. This, in these situations, we will always choose tuple instead of list. And one more thing is there, uh, tuple occupies less memory instead of list. Why? Because you don't know, the computer doesn't know ki whether you want to increase the list or not. So for that there is a specific space always engaged whenever we assign a list. But in tuple, the interpreter knows once it is created, it is not changeable. That means the lesser, the more compressed version is tuple. So this is how all about tuple. More or less we have covered so many things about tuples. Just let me know how can you apply this in your program or in your code, and just drop a comment how you would like this.